Thank you for registering for a class today on Autodesk Inventor for the wood trades. My name is Steve Whittam, and I consider myself an Autodesk Inventor evangelist when it comes to utilizing these tools for the wood trades. Today's class summary will cover quite a bit of material, and we'll try to handle all of that within the next 1 hour. Our objectives, again, are quite full, and I do hope that each of you will have a much better understanding after our session. Today, we're going to build a basic cabinet that is nothing more than multiple pieces of material put together with all the hardware, all of the cutouts, the negative shapes, the pilot holes that would be necessary to machine this and build it. As you can see, we do have all of the dowels, pins, pilot holes, everything that's necessary for correctly fabricating whatever we design. So that is going to be the results that we're going to be looking for. Today's first topic will be modeling. The type of modeling I prefer to do is a hybrid between solid body modeling, adaptive modeling, and top-down modeling. Let's get started. So we'll get started by first creating the first part. And the first part will be the outside frame, which is nothing more than a rectangle that I'm now adjusting the dimensions, and I'm going to say it's 60 by 30. I'll do a simple offset so that I have the thickness around the whole piece. And let's say it's 3/4 of an inch, but this I'm going to say thickness equals so that thickness becomes a variable that I can adjust later on. I'll now extend the vertical lines so that they're physically going to create a joint. By doing that, I now have to add dimensions to the top, the bottom, and the left-hand side, and again I'm making them all equal 3/4 of an inch or thickness. Okay, once I've got that, next step is maybe let's create the bottom horizontal member that is in a dado. And we have no dado at the moment, so what I'll do is I'll just create the rectangle that goes through the side pieces, add a couple dimensions that I want, so they'll equal 3/4 of an inch, and whatever the opening that I'm looking for at this moment in time. So 5 3/4 of an inch. Now, these dimensions will control the item later on. What I'm now also doing is I'm going to say the depth of the dado is going to equal the thickness divided by 2. Thusly, no matter how thick the sidewalls become, the dado will always be half of the depth of cut. Again, planning for the future, this could be a prototype item that I use over and over again, and it gives me the ability to quickly just change a couple dimensions and get end results. Trim up what I don't want, basically creating my dado, making sure all my constraints and dimensions are there, and we move on. Next, let's create a center divider. Center divider will be fixed. We'll say it's equal to thickness, and I'll set it to vertically be placed in the actual cabinet itself. Thusly, change the width of the cabinet, and it stays centered. I'm now doing some of the dividers at the bottom piece. Just draw in a sketch. It doesn't have to be exactly correct. Add a couple of constraints. These are collinear constraints, and say it's 3/4 of an inch. Okay, and make it equal the original. Again, I'm a true believer in trying to make things as simple as possible to get our work done. And then, as I did before, I'm going to say that the depth of the cut into the bottom rail and the fixed rail is going to be thickness divided by 2. So that will always allow me to have a dado half the thickness of the material. Again, completely up to me. Now, I want them centered. I want to center it in the bottom, thusly that no matter how wide the cabinet becomes, these will always be centered. Three separate openings. So I just draw some simple lines. I'm going to highlight each line. I'm going to go up to the top and say it's a construction line and also make them equal, and immediately what just happens is that it now has equal opening and I don't have to calculate anything. change the 60-inch to something else, and it automatically will still continue to become equal information. Now I also decided I'm going to make those half an inch, not 3/4, and you can see the data changes with me. So again, it starts the tool of becoming parametric. Next, let's put a shelf in here. And what I've done before, again, we'll say it's the tops and the bottoms of these shelves are collinear, so they line up immediately. I'll also say it's 3/4 of an inch, equaling thickness. And now offset the edge, let's say it's a 1/16 of an inch, and we'll go ahead and we could type in a 1/16, we could type in decimals, we can type in metric. Inventor allows me to do any of those things. And all I'm doing here is, again, just going through the routine of picking the dimensions and letting them equal each other. Okay. And now what we also might do is we might want to center the shelf in the opening, and that's exactly what we did. So as you can see here, I'm cleaning up the dimensions right now just so that they're easier for me to see, easy for me to control, because this is a model that I might be using over and over and over again when I do this type of cabinet in the future. So one cabinet, one time. From this point, we'll turn more towards an isometric view. We'll start extruding each of the closed loop members, and we'll start creating solid bodies out of those members. We'll also say the depth of the cabinet equals 14, so one variable will be able to change the depth of every member. Now, once we do the first extrusion, we want to share the sketch so that we get the sketch back so we can start extruding each of the other closed loops, and we're going to pick the parameter depth as our actual value. So we'll go ahead and extrude each of these. We want to extrude, we want to make sure we say it's a solid body, not just a normal extrusion, so that when we're finally done we should have about 10 solid bodies, and we'll then have to add the back to this particular unit as soon as I've extruded all of the pieces that I'm working on at the moment. So again, it's a lot of it is similar over and over again. So the first one you do might take a little bit of time, but a cabinet like this shouldn't be more than a half an hour to an entire finished piece. And this is going to be absolutely parametric, so that I'll be able to change it at any time to any dimension I want. So we'll put the shelves in. Now I don't particularly like the shelves flush to the front, so there's so many ways of manipulating it. In this particular case, I'm going to use the thicken command, and I want to reduce it by a value of 1 inch. So I touch the face, I'm going to cut into it 1 inch, and I'll cut into each of the pieces 1 inch. Okay, so again, lots of different ways of attacking how we get to an end result, different workflows that each of us might want to use or not use. This is just one way of accomplishing a task. So let's flip this over. Let's create a new sketch on the back, and I'll sketch on the back surface of the vertical member. So I have my start point, and then I'll use the project tool and touch a corner. Once I've done that, I'll create a rectangle starting at one of the corners to the other corner, and then extrude it, a value of, most of the time it's a ½ inch back, but again, whatever you want. This is a back that actually rides all the way across each of the sides. And you can see that we've accomplished our goal and we've created the basic cabinet. Now, just to show you, we could change the values. Let's say we want to change the horizontal and vertical value from one value to another. By hitting the update button, you'll notice that it is already parametric, but it's still a single solid. If we go and take a look at the thickness tool, we can show it that when we change the thickness in parameters, you'll see that the joint just changed also. So again, we just basically tested the world that we've created. We can say that the thickness of the material is 3/4 of an inch, and the depth of the cabinet is 24 inch or what have you. And you can see that it is changing on us automatically. Change the thickness back to 3/4, and that of course now updates our cabinet. So we're in pretty good shape here. It looks like we can change anything we want, and nothing is failing. I've tested the waters. Everything is staying actually centered. The openings at the bottom are always equal to each other. So I've proved out my first steps. You'll see that there are certain the solid bodies. Every time I extruded something, it became a solid body. Now, what I'm about to do here, or doing, is I'm basically typing in their names. Each of the parts, each of these extrusions should have a separate name, because the end result to what I'm going to do here is that it is going to create single parts that can be manufactured. And I have to know what the part names are, so I'm now giving it. So as I touch each of the solids, it lights up in the isometric view. So I'm naming things like left side, top, right, bottom, what have you. I can double click on it to name it, or I can right click on the actual part and go to properties and rename it there. So there's lots of different approaches again to renaming, but this is just one of them. So we go through the process, we name it whatever we want, and if it's 2 parts or 20 parts, this is the way it's done, because every time you do a extrusion of a solid body, it gives it the next sequential number: solid 1, solid 2, solid 3, solid 4. Now, once that's accomplished, okay, I'm going to do a couple more unique kinds of things here, and I'm going to tell Inventor itself that I want to prefix any of these solid names with the name plywood. Okay, plywood dash. So when I start creating my assembly, it will have that name. So right now this is a single part. It's called master.ipt. And what I'm going to do is go up to Manage, Make Component, and I'm going to touch each of those items, each of the solid bodies, and it's going to create a new file, master.iam, or an assembly file. As you can see, the component names are all plywood, left side, right side, and so on. So it did correctly name the things that I asked it to name. Once I hit OK, what just happens is that it now creates an assembly file utilizing all of the parts from the part file, or all the solid bodies from the parts files. And just to test it again, what I'm going to do is touch the right side, take the grounding off, and I'll pull it apart and see that it actually moves independently. So I can move it away from each other. I have my joint there, and it's a real part that now can be machined. So quickly from the original to this, and you could see that I'm about to hit save, and this is going to save each of the individual parts. You can see the naming conventions in the browser all say plywood whatever. And now not only do I have a assembly file, but I have a part file. I have both of these working together. Now if I change the master part file, as you can see I'm changing it from 70 inches. When I do an update, okay, the assembly file will change. If I change the depth from 24 inches to 14 inches, okay, you'll see that the part file just changed. Once I go back to the assembly file and do an update, you'll see that the assembly file changes. So in other words, what I have here is a master part file that's controlling my entire assembly. A very, very simple way to do things. I don't have to add any constraints whatsoever to the system. And again, it's a matter of just changing the original part file by the parameters that I had already preset, doing an update, going into the assembly file, and doing an update there. So this is called solid body modeling, and it's a very functional way to start building. Hit save, and we'll move on. The second area that we're going to discuss is the assignment of materials. This is where we tell Inventor it's made out of solid stock material, plywoods, what the grain direction, how the edges are treated. Very important when it comes to woodworking. Because of Autodesk's open system of customization, we're able to put together menus and changes in the API that really has changed the way that we address this and have become much, much more effective. So let's take a look at this. Now, if we go back to the model and we look at it, we want to go up to what we call furniture design and go to material assignment. In material assignment, there's something called part type. And in part type, we can tell the system that it either will be edge banded, it is made out of plywood, it's a board, or it's made out of solid stock, which is a profile. We have other functions in here, but for the moment, this is what we're going to present. So we're now saying that everything in the system is going to be plywood. Now, the reason we're doing that is so to show you that once this is done and we assign a material, and we have multiple materials. This is not the material list that comes with Inventor. This is our material list that we can add to, change, alter, change the code, change the texture, change the grain. All these things are fully customizable and adjustable. So I created two materials called my own and my own B, which is a maple looking type of material, and I'm going to pick the wrong one. And you can see the grain direction is the short way. And if I click on the bottom button, what it'll do is it'll assign everything that material, that the entire project. Now we can either do a global change or we can pick individual components. So either way will work just fine. And again, as I said before, the grain will run the wrong way in this particular situation, unless, of course, that is what one desires. Grain is nothing more than JPEGs or bitmaps that we can grab from any different source on the internet. So you can see that it's going the wrong way. So at this moment, I'll just go back to my material group and say I want to change the grain, and you see the grain change. And now I hit OK, and because I'm saying global, everything is going to change. So either pick individually or everything, and I don't have to worry about it. I don't have to go and touch each individual item at any, individually and work through that. Release 2013 is a little bit better in that way, but it's still not as fast. Now, if we look at the model, after I've accomplished this, look at the edges. The edges show up totally different because if they're plywood, okay, or MDF or anything else, they'll show that the edge conditions should be taken care of, or they're raw. Now, the next thing I'm going to do is I'm going to just assign the two shelves a whole different material just by picking both of them and hitting OK. And because they're plywood also, you'll see that the edge conditions show up in that fashion. So if I go ahead back to what I call part type and say it's made out of solid, you can see the edge conditions now show up as solid material. And of course we can make the bottom dividers a different material also. So basically just click and pick from a library. Now the next process within our system is again to take a look at the different functionality that we have. Okay, and again we go back to the material group and you can see that the bottom line is blank where you can start adding more materials. Now if we want to edge band, and that's very common, we have an edge banding group it's called, and if we move to the right you'll see that here's all your edge banding. The code number, whatever you want to name it, and then the thickness of the edge banding itself, and you can have literally hundreds or just a couple, whatever the company uses. Now when we decide on the edge banding, you can see the list. We're going to say it's a 45 mil. It shows you the color, and now you tell it whether the edge banding will decrease the size of the blank by the thickness, or the edge banding will increase it by the thickness of the edge banding. And once you do that, all you're going to do now is go ahead and touch any of the edges that have the checkerboard pattern, and what that will do is of course it will then apply edge banding to those edges, showing you, the user, the designer, that those edges have been taken care of. Now they don't necessarily have to be edge banded. We can of course put some realistic molding around it, or anything else that we so desire. So we're not limited to what we can do here. It's just is giving us functionality that we really didn't have in other areas. And again, this is absolutely customizable, and the edge banding, of course,